Today, we're going to talk about rational exponents. So, the exponents with the fraction form, right? As you see here, all these fraction exponents, that's what we're going to talk about. Remember, when we're talking about fraction exponents from the other sections, we said that if you have m to the n's exponents, your exponent's numerator is power, denominator will be index. So this will give you n's roots of x to the m's exponents, or n roots of x to the m's exponents. So again, numerator is going to be power. Denominator exponent will be index of the radical. So using that, let's see if we can do a few examples. So this example right here, we should be able to convert it because your denominator is 2, means you're going to have a square roots. Numerator being 1, you're going to have power of 1. So that will be look like this. And we know that square root of 4 is equals to 2. This one, because your denominator is 3, it means you have a cube root. And because you have a parenthesis, make sure to put negative sign inside. And we know that's equals to negative 3. This one right here, we do not have a grouping. Right? No grouping. So this exponent only apply 32, not the sign. So in that case, we're going to have negative fifth roots of 32. And fifth root of 32 is equals to 2. And you have negative in front of it. This one is going to be square roots of 8. And when you reduce square root of 8, 8 being 2 times 2, this 2 matching, because you have to have 2 matching inside of square root to bring it outside. So square root of 8, when you simplify, you get 2 square root of 2. Right? Your solution should be always simplest form. Okay, then let's look at next one. What about this one? This is a cube root, right? Cube root of 16. 16, we know that's equals to 2 to the 4th exponent. So out of 4, 3 will be out. The one that didn't have 4 matching will stay inside. This one, you have a power also. You have a cube. That's the power. That's the index of the radical. So this is going to be square root of 4. And I know I can reduce square root of 4 to become 2. So maybe I will use the power after I reduce the number, right? So this will give you 2 cubed, which is 8. What about this one? This is going to be cube root of negative 8. And again, I know I can reduce that, which is going to be negative 2. So if I know that I can reduce the value using the radical, then I will use the power after, right? Because smaller number powering is easier, which will give you positive 16. This is going to be 6 over 4th exponents. Obviously, you can reduce that fraction into 3 over 2. It means you have a square root of 4. And we know that's something that we can be able to reduce. So I will use the power after, which will be equals to 8. Okay, let's try a few more. So this section is all about how to use the fraction exponents, right? So this is very basic one so far. When you have a negative, we can flip the base And without the negative exponents, use the positive because you did flip the base. And then you're going to apply the fraction exponents. So you're going to end up using fifth roots of negative 32. We know that's going to be 2. And square that. I mean negative 2, right? And square, which will give you 1/4. So just apply all those rules that we went over from different sections of exponents and use them all, right? So I usually like to get rid of the negative sign first. Then it will be 1 over negative 32 to the 3/5. Use the fifth roots. And then cube, right? So it will be negative 2 cube, which is going to be 1 over negative 8, right? So that's how you're going to work on all these problems. Should we do 2 more? Applying negative. Use the cube roots and power. You get negative 3 square, which is 9, right? Once you get used to it, it will come faster or easier. This one, get rid of negative exponents, use the square roots. Square roots, I cannot reduce it, so maybe I will put cube inside so I can simplify first. Cube means you have 3 out of 3, 2 out, 1 will stay in. Example 2 is the same thing. It's maybe a little more involving. So let's see what we have here. Fourth roots of 7 to the power. We wanted to simplify it. So what we can do is converting into radical into power, right? So then it will give you 7 to the 1/4. And you had square before, which will give you 7 to the 2/4. You can reduce that. It will give you 7 to the 1/2. So it will be just square root of 7. Just looking at what it's given, sometimes you're not really understanding what you need to do to simplify. Why? Because this one, obviously, one was radical, the other one was power. And we don't know the relationship yet clearly, right? So if you didn't know what to do, trying to make it as the common as possible so that you can apply all those knowledge about the exponents, right? So that's what I did. Fourth roots changed to power 1/4. On the rule of exponents, you can multiply this 2, which give you 2/4. You can reduce 2/4 into 1/2. That's going to be square roots. Usually, if problems start with the radical, your solutions, you want it to have a radical form. Let's look at the next one. What about this one? So because we just had experience, I can see that this 2 can maybe reduce it, right? So I will change that into fraction and reduce. 3 goes into 9 3 times. So this is going to be just cube root of x. Again, this is going to be same thing, right? So you can convert this into the fractions, which will give you 9/3 this time, right? Power is numerator. That will give you 3. 4 to the third power is 64. What about this one? Remember, you cannot multiply if you don't have a same index, right? In the radical. look like this have a cube, this have square. So as it is, you cannot combine any further. But let's see what happened when we change to exponents, right? So this is going to be 4 to the 1/3 times 2 to the 1/2. Once you change to exponents, you kind of know that you can multiply if you have a same base, where you do not have same base at this point. This is 4, this is 2. But I know that 4, you can convert it into have a same base 2. 4 is 2 squared. So then double exponents means multiplying. Once you have same base, add the exponents, right? Fractions, additions, you have to have same denominator. So 2/3 become 4/6. 1/2 become 3/6, which will be 7/6. Your problem started with radical, so your solution, you wanted to put it in a radical. So it will be 6 roots of 2 to the 7 exponents. And that's same as you have a 7 2's inside of 6. So 6 of 2 can be out and 1 will stay, right? Okay, so let's try another one. This one right here, what do? We cannot combine as the radical, so we're going to change it to exponentials because we have more rules that we understand better on the exponents. So once you change to exponents, let's apply same same base, so we should be able to add the exponents. Order to add, have to have same denominator of fractions. So 1/2 become 2/4, which will be 5/4. And that gives you 4 roots of y to the 5th. And bring 4 of y out, and just 1 will stay inside. Example 3 is going to be the same thing, but more variable, right? Getting longer problems. Even it's longer problem, just work one at a time. So what I see right here, you have a same base. You cannot combine the same base until you get rid of the parentheses, right? So let's try to get rid of the parentheses. This one right here, you don't have any exponent outside, so you will just get rid of this without doing anything. But this parenthesis right here, you need to distribute 1/2. So you get -2/2 and y to the 1/2. Once you get rid of parentheses, now combine the like terms. So this 2, like term, this 2, like terms. On the x, you're doing 2/3 plus minus 2/2. 2/2 is equals to 1, which you should be able to change into 3/3. So for x, you get 1/3. What about y? You have y. Without the exponent right here, it means you have 1 and plus 1/2. That gives you 2/2 plus 1/2. So that's going to be 3/2. And don't forget that was 2 over 3 minus 3 over 3, so this should be negative. So then the last thing you wanted to do is get rid of your negative exponents. And because your problem started with exponential, not the radical form, exponential form, so you can leave your solution into the exponential form like this. So the simplest form, you should not have negative exponents or having only one of the same base. Let's look at the next one. This one, I only have 1x, 1y. All I need to do is just distributing, open the parenthesis, and get rid of negative exponents, right? So then I need to distribute negative 3 to the number. And this is going to give you negative 3 over 3, which is negative 1. This is going to be negative 2 times 3 is 6 over 3. When you reduce those fractions, this is what you have, right? Once you reduce fractions, now let's try to get rid of your negative exponents. So 2 cubed on denominator, x to the first on denominator, y to the square on the numerator. And look like I can also write 2 cubed into 8. Right? Let's try one last one. Okay, so this one right here, I see more than 1x and more than 1y, so somehow I need to combine that because they're all inside of the parentheses. You should be able to combine them without distributing, right? Let's do that first before distributing 1/2 exponents. So then you're going to get x squared minus 1/3. And maybe I'm going to bring down into denominator, I do 1 minus 1/3. Don't forget, we didn't do anything with outside exponents. And let's do that subtractions on the side. 2 minus 1/3 is equals to 6 over 3 minus 1/3, which is 5 over 3. So I will have x to the 5 over 3. And when we do 1 minus 1/3, that gives you 3 over 3 minus 1/3. That's 2 over 3. Let's distribute exponents. When you distribute the outside exponents, make sure you apply to all the term, right? So you're distributing it 3 times. Gives you 9 to the 1/2 x. 5 over 3 times 1 over 2 is 5 over 6. 2/3 times 1/2 is 2 over 6. Let's see if we can reduce. 9 to the 1/2 is same as square root of 9, which is 3. 5 over 6 exponent will just stay as it is, but 2 over 6 is 1/3. So denominator, you will have y to the 1/3 exponent. If you check my notes, this problem, I work it differently. I distribute exponent first, right? So if you wanted to see different way of solving exactly same problems, maybe you can check that out from the notes.